Wherever you get your drinking water from, the tap, a bottle or a source, your water will not just contain pure H2O, but what is in your water? And more importantly, what should definitely not be in there? Well, welcome to the Drinking Water Treatment Lecture about water quality aspects. My name is Doris van Halem and I'm an assistant professor in drinking water. Today I'm your lecturer and I will introduce you to 5 groups of water quality parameters that are used to assure safe drinking water supply. First, organisms in drinking water, health-related chemical parameters, aesthetics of drinking water, and operational parameters. Well, the first group of key compounds in water consists of living creatures, which you most often cannot see with the naked eye. In nature, water contains all kinds of organisms and they are present in large numbers. Also in drinking water, many different organisms are found. Generally speaking, these organisms can be divided based on their size into 4 groups: higher organisms, protozoa, bacteria, and viruses. While higher organisms have a size between 0.05 and 10 millimeters. And just to give you an idea, a cubic meter of water may contain over 50,000 of these organisms, which give you the impression of a large zoo and seems unsuitable for drinking and to be avoided by vegetarians. However, fortunately, a characteristic of most of these higher organisms is that they are harmless to human health. Their presence in drinking water is only aggravating if they are detectable by the naked eye. An overview of higher organisms as typically found in drinking water is depicted in the slide. Also, smaller microorganisms such as bacteria can be abundantly found in water, and the majority of them does not affect your health. However, there are also microorganisms that are harmful to human health, the so-called pathogenic microorganisms. Pathogenic microorganisms, or pathogens in short, are not present in water by nature, but they enter the water through feces and urine from humans and animals. Pathogens have difficulty to survive in natural water because the temperature of water is lower than body temperature. An important source of pathogens in surface water is the continuous supply of untreated or not fully treated wastewater from domestic and bioindustry. Pathogenic microorganisms can cause different diseases, which may become epidemic rather quickly in water. They can be divided into 3 main groups, each with their own individual characteristics. Protozoa, which are single-cell animals and can cause diarrhea and stomach complaints. Bacteria, responsible for typhoid fever and cholera. And viruses, the smallest organism of the 3 groups and responsible for hepatitis and polio. The size of bacteria, viruses, and different particulate matter in water determines to a great extent their removal potential by treatment processes. There are analytical techniques to determine what pathogens are in your water, but for safety reasons it is preferred to measure indicator organisms and not the real disease-causing organisms. For bacteria, coliforms or E. coli are used as indicator organisms. They can also be found in human and animal feces, but can be more safely cultured and counted as colony-forming units per volume. For virus indicators, mostly bacteriophages are used, which form plaque-forming units per volume. This picture shows an example of a plated sample for E. coli counts. Each dot represents a colony-forming unit. In the guidelines of the World Health Organization, it is stated that when testing a 100 milliliter sample, no E. coli may be found. Well, let's go to the second group of parameters important for safe drinking water, which consists of dissolved compounds, both inorganic and organic. A subdivision can also be made based on the concentrations present in the water as macropollutants for concentrations over 1 milligram per liter and micropollutants for concentrations below 1 milligram per liter. The long list of health-related chemical constituents can be divided roughly into metals and related substances, such as lead, mercury, arsenic, organic micropollutants, for example pesticides and hormones, disinfection byproducts, such as bromate or trihallomethanes, and other compounds, which include nitrate and fluoride. Well, guidelines for the maximum allowable concentration exist for these substances based on considerations such as health impact, detection limit of the measuring device, or the available removal technologies. The impact of a substance on human health depends strongly on the specific constituents, making dose response and epidemiological studies crucial. Most countries have their own guidelines for these parameters. There are also international guidelines, for example of the World Health Organization and the European Union. In EU guidelines, a maximum allowable health risk of 10 to the minus 5 is used for the formulation of the guidelines. In other words, it is accepted that no more than 1 in 100,000 persons can develop an illness for each contaminant. Well, let's briefly go through the different chemical contaminants that can threaten safe drinking water supply. Metals and related substances include well-known heavy metals such as mercury and lead, but also the metalloid arsenic. These contaminants originate from different sources, including natural release into the water from sediments, through mining activities, and industrial or domestic discharges. These metals and related substances pose a serious threat to human health, as they are often carcinogenic and may cause illnesses to the bladder, lungs, and other organs. Another group of chemical compounds that may be present in source water are organic micropollutants, shortly called OMPs. This group includes contaminants such as pesticides, pharmaceuticals, human care products, drugs, and gasoline. Depending on the dose, these compounds may be genotoxic and endocrine disrupting. A particular concern is the potential mixture of many different of these organic micropollutants, such as a cocktail of substances, as it's difficult to detect and to remove. Disinfection byproducts are originally not present in the source water, but enter the water during a treatment process for disinfection. Disinfectants react with natural organic matter or bromide in the water, resulting in carcinogenic byproducts. Trihalomethanes and DMA and bromate are examples of disinfection byproducts, which are produced by chlorine, chloramine, and ozone, respectively. In the group Other Compounds, I want to mention nitrate and fluoride specifically. Nitrate enters the water in areas with agriculture and is particularly of concern for babies and pregnant women, as nitrate is transformed to nitrite in the body. Fluoride can be naturally present in groundwater and at elevated levels is also a threat to human health, as it may cause brittle bones and tooth decay. Well, now you have been introduced to the most important parameters that can have an impact on human health. These microbial and chemical parameters are crucial for the safety of drinking water. However, also the consumer comfort and perception is a key component to take into account. Therefore, the third group of water quality parameters is aesthetics of drinking water. The water should not only be safe, but also be perceived as safe. Odor and taste are subjective parameters which cannot be detected by any device. The acceptable taste and odor of water are determined by using consumer panels, which determine whether they detect an unpleasant flavor or smell to the water. Color and turbidity can be measured in the water, as well as the constituents influencing the aesthetics of drinking water, such as iron and sulfate. Also, undissolved matter or suspended solids can cause discoloration or turbidity to the water. Undissolved matter consists of large or small particles, which have not been dissolved in the water. This is a different group of contaminants than the earlier mentioned chemical substances, as these are generally dissolved in water. A distinction based on size is made between suspended and colloidal matter. The diameter and specific gravity of particles are important for removing them from the water. Colloidal particles are very small and have a specific gravity similar to water. Colloidal particles generally have a negative electric charge, and the electrostatic repulsion makes them difficult to remove. Operational water quality parameters are very important for drinking water supply companies. The objective of these parameters is to assure that the water quality is maintained post-treatment. So, the water quality should not change because of storage in reservoirs or distribution and use within household, such as heating. A distribution network can be an important source of contaminants as organisms may grow in it. Important parameters contributing to the growth in distribution networks are the organisms themselves, but also nutrients, temperature, bicarbonate for buffer capacity, and dissolved oxygen. Apart from growth during distribution, also dissolution of pipelines should be prevented. So aggressive water should be prevented. For this reason, saturation index, hardness, and pH But also the hardness of water, as calcium and magnesium ions, is important, as it may cause scaling in heating installations, a film on tea, and less effective use of detergents. Well, now you know the main water quality parameters that you need to pay attention to when designing a water treatment plant. Also, you have learned about their effect on human health, consumer demands and operation. The next step will be to learn more about how you can remove these constituents from the water. We've come to the end of this lecture, so I want to thank you for watching, and please use the discussion board for your questions.